So for this video, we are going to complete a stationing MoBoard, and this particular stationing MoBoard is going to include a dog leg. All that means is you're going to drive 2 different courses in order to take station onto the guide. So let's go ahead and go over the problem. You are in open ocean and the guide bears 180 degrees true at 4,000 yards. The guide is on a base course of 270 degrees true at 15 knots. At time 0600, you're ordered to take station 270 degrees relative, 4,000 yards from the guide, doglegging 2,000 yards dead astern of the guide. Stationing speed is 20 knots. So let's break down what is given to us in the problem. First thing that we're gonna go ahead and do is plot out our knowns. So first known that we have is the base course and speed of the guide. That is 270 degrees true at 15 knots. So I'm gonna go ahead and plot that. The reference ship or the guide is on a base course of 270 degrees true at 15 knots. So that is my ER vector. Remember, ER vector is the true course and true speed of the reference ship. In this case, the guide is the reference ship. We are not. Next piece of information that is given to us is the fact that the guide bears 180 degrees true at 4,000 yards. So this is where it can get a little tricky sometimes. So imagine that this crystal here is the guide ship, and we are somewhere floating around in the ocean. From our ship, if we were to look down a bearing of 180 degrees true, we would see the guide. So I'm gonna place myself up here. So if my ship is here and I look out of the window of my pilot house and I'm looking at this ship or the guide, that means I would be looking down a bearing of 180 degrees true. Now let's say for some reason my ship was over here instead. This is the position of my ship. And if I were to look out of the window of my pilot house and I saw the guide ship, if I'm here and I'm looking to see the guide, that means I'm actually looking down a bearing of 000 degrees true. So that's how I know that my ship is up here. Because if I'm here, in order for me to see the guide, I have to be looking down a bearing of 180 degrees true. So now I'm able to plot myself. So it means I'm going to be up here at a distance of 4,000 yards from the guide ship. So I'm gonna make my mark here at the 4,000 yard ring, and that is going to be my M1. The next piece of information that I am given is the fact that I'm ordered to take station down a bearing of 270 degrees relative at 4,000 yards. So again, if my ship is here, the guide ship is here, and they are facing this way, meaning the ship is facing this way. So if this is 000 degrees relative, this would be 090 degrees relative, 180 degrees relative, and 270 degrees relative. So that means that I need to end up right here down a relative bearing of 270 degrees at 4,000 yards. So this point becomes my MF, or M final. Some people label it as M3, and that's typically what you will see, but there may be an instance where you have to dogleg multiple times. So I just label mine as MF to remind me that this is my final position. Next piece of information that is given is the fact that I am going to be doglegging 2,000 yards dead astern of the guide. So that means that I'm gonna have to make a pit stop here at 2,000 yards dead astern of the guide. So that becomes my M2. So now I have M1 to M2, which will be one leg. Then I have M2 to M3, M2 to MF or M3, which would be another course that we have to drive. So all we're gonna do is we're going to solve this as 2 separate stationing problems, all right? So for the first stationing problem from M1 to M2, all I am going to do is line up my weaves between M1 and M2. I'm going to draw this line of relative motion between the two. And I'm going to parallel that same line down to the tip of my ER vector. Draw that line in the same direction. And now I have my RM line of possibilities. So all that means is my point M that I used to solve the speed triangle is going to be somewhere along this line. So now I need to figure out how to plot that point M. Now from the problem, it says that the stationing speed is 20 knots. So I know that my stationing speed is going to be 20 knots. So all I'm going to do is come over to my speed scale, or this 5-to-1 scale, measure out 20 knots. Now remember, it's 20 knots of true speed. So since it's true, that means it's going to come from the center, from E. I'm just going to see where that intersects this RM line of possibilities. And that, in fact, intersects it right here. So this point becomes M. So now I have completed my first speed triangle. So if I were to connect E to M, get that EM vector, that is going to give me the first course that I have to drive. So for course 1, course that I'm going to be driving is going to be 195 degrees true at a speed of 20 knots, which was given to us in the problem. Now we need to figure out how long we are going to stay on this particular course. We need to figure out how long it's going to take us to travel from M1 to M2. So all we're going to do is we are going to figure out what the MRM is. So what's the distance between M1 and M2? We are using the 1-to-1 scale. So I got my MRM. I'm gonna label this MRM1 to be a distance of 4,400 yards. I'm going to bring that down here to the distance scale. If I'm looking for time, I need an SRM, or I need a speed. I need a speed of relative motion. So all I'm going to do is measure the distance between R and this M. Bring that over to my speed scale. That gives me a speed of relative motion of 21 knots. And then, as before, all we're going to do is connect these 2 points on our nomogram. That's going to give me a time of 6.5 minutes. So 6 minutes and 30 seconds. So what that means is I'm going to be on this particular leg of my transit from M1 to M2 for 6.5 minutes, and I'm going to be driving a true course of 195 degrees true. So now I want to figure out the true course and time that I'm going to be on this leg from M2 to MF. So I'm going to switch over to this pink pen, and I'm going to do the same exact thing over again. I'm going to solve this as a completely separate stationing problem. So I'm going to connect M2 to MF, get a new LRM. I'm going to bring that to the tip of my ER vector. Now I have a new RM line of possibilities. So all that means is that my point M to complete my second speed triangle is going to be somewhere along this line. I'm going to figure that out by plotting my stationing speed of 20 knots, which was given to us in the problem, along this line. So I'm going to come over to the speed scale, measure out 20 knots again, come from the center of my MoBoard. I'm going to see where that 20 knots intersects that RM line of possibilities. And it intersects it right here. So this point is my second M. So now I'm able to complete my second speed triangle. So I connect E to M. So the information for course 2, I'm able to figure out that the second course I have to drive from M2 to MF is going to be down a bearing of 246 degrees true. I know that the speed is 20 knots because that's given to us in the problem. Now I need to figure out how long I am going to be on this course from M2 to MF. So I'm going to solve it the same exact way. I'm going to figure out what the MRM is from M2 to MF. I need to figure out what that distance is. Got that distance to be, just so happens that it is again 4,400 yards. So this MRM just happens to be 4,400 yards again. And now I'm going to figure out what the SRM is. So I'm going to measure the distance between R and my pink M. Bring that over to the speed scale. I have that as an SRM of 9 knots. With the distance, or the MRM, of 4,400 yards again, which is pure coincidence. Line those up. I'm gonna get a time of 15 minutes. So what that means is from M2 to MF, or my final position, I'm gonna be driving a course of 246 degrees true for a time of 15 minutes. So now we have solved our dogleg slash stationing MoBoard problem.